Good morning to all of you. In our last two videos, we have been discussed about Miller indices or crystallographic planes. So how we have to draw the crystallographic planes, or how we have to find out the Miller indices from a crystallographic plane or lattice plane, that we have been discussed in detail in that two videos. So today we are going to discuss, or we are going to try to solve the problems or the questions whatever I given in the video 1 and video 2 for your practice. So with the help of this video, you have to match whatever you done or whatever you have been answered your question, you have to match with the help of this video. So let's start to answer the questions. First we have to consider the video number 1. Video number 1, or you can the lecture 1. Okay. In that video I given some questions that you have to find out, or you have to draw the planes from the Miller indices. So these are the simple steps we have to follow, and the detailed steps and the procedures we have been discussed in that video. So we have to just go through the steps that from Miller indices, whenever we want to find out, or we want to draw the plane, first we have to take the reciprocal of the indices. Then these reciprocals will be the intercept of that plane, and by considering these intercepts we have to draw the plane. So these are the indices of a plane, that is the numbers which is enclosed by the circular bracket. So by considering the steps or the methods, we have to take the reciprocal of these numbers, that it is 1 by 1, 1 by 2, 1 by 3. Okay, or it will be equal to 1, 1 by 2 and 1 by 3. Now these are nothing but the intercepts of the plane whatever we want to draw. So these are the intercept, means the planes cuts the x-axis at 1 unit, cuts the y-axis at 1 by 2 unit, and cuts the z-axis at 1 by 3 unit of the unit cell. So to draw the plane, or with the help of this intercept, if we want to draw the plane, first we have to draw a unit cell. So this is the unit cell. Let this is x axis, this is y axis, and this is z axis, and the origin of this unit cube is at O. Okay. So now we have to take the intercepts to draw the plane, that 1 unit along x-axis. That means the plane will be cut the x-axis at 1 unit. So this x, y, z, this is z-axis. Okay, this x, y, z, also called as unit translation vector, can be denoted by A, and this is B, and this is C. These are detailedly we have been discussed in that video number 1. So for x intercept it is 1, for y intercept it will be half, middle of this line, and for z intercept it is 1/3. 1/3 means 1/3 of this line, approximately it will be here. Now we have to join these 3 points. The enclosed plane, after joining, the enclosed plane is represents the required plane. So this is the plane, or we can say that this is the crystallographic plane having the Miller indices is 1, 2 and 3. Now we have to consider the second question, that is 0, 0 and 2, having the Miller indices 0, 0, 2. For that we have to first find out the reciprocal of these indices. Reciprocal of these indices, that will be 1 by 0, 1 by 0 and 1 by 2. That will be equal to infinite, infinite and 1 by 2. So these numbers are represents the intercepts. The intercepts of the plane having the Miller indices 0, 0 and 2. So here x intercept is infinite, y intercept is infinite. That means the plane is cuts the x-axis and y-axis will be at infinite. So that means the plane is parallel to both x and y-axis. Suppose I can say that this is the plane and this will be x and y-axis. The plane will be wherever we have to draw in this cube, the plane has to be parallel with both x and y-axis. If we have to consider this is the plane, then it has to be parallel to x and y-axis, because the intercepts of this plane for x and y-axis is infinite and infinite. That means this plane will be cut the x and y-axis at infinite. If I will extend this plane towards x-axis and y-axis, this plane will be cuts or tends to cuts at infinite and infinite. So that from these intercepts we have to draw the plane in the cube in such a way that it will cut the z axis at 1 by 2 unit, and it will be tends to cut the x and y will be at infinite and infinite, or we can say that plane will be parallel with both x and y axis. In detail we have been discussed in this video. You can follow this video again for your further clarification. So first we have to draw the plane, one unit cell. This is the unit cell. We have to draw the unit cell x or A, we can say. This is Z or C, we can say, and this is our origin. So here z axis, the plane having the intercept on the z axis is 1 by 2. That means the plane has to cut the z axis here and parallel to x and y axis. That means if we have to consider any plane, this is the plane, it has to cut here but parallel to x and y axis, means it will be cut like this. If the plane will be passed through the cube in this way at the point 1 by 2 for z axis, then the intercept of this plane for z axis will be 1 by 2 and intercept for x and y will be infinite and infinite. Hence the required plane will be this one. So this is our required plane having the Miller indices 0, 0 and 2. Now we have to consider question number 3. For that, first we have to find out the reciprocal. Reciprocal means 1 by 1, 1 by 0, 1 by 2. Okay, that it will be give 1, infinite and 1 by 2. So these are the intercepts. That means the plane has to cut the x-axis at 1 unit and y-axis at infinite unit. That means the plane has to be cut the y-axis at infinite. parallel to the y-axis, or it will be cut the y-axis at infinite, and the plane has to be cut the z-axis at 1 by 2. So we have to draw the unit q first. This is y, x and z. Okay, first we have to mark where is the intercept will be. On the x-axis it will be here, because it has only one intercept, it is 1, and on the z-axis it is, so if it is 0 origin, so from origin we have to move along x-axis 1 unit, along z-axis 1 by 2 unit. So here we got the two planes, and by using the two plane we have to draw such a plane which will be parallel to the y-axis, because the intercept for the y-axis is infinite. How we have to draw? See, if this is the plane, and if I am going to be placed like this, then it will be cut the z-axis at 1 by 2 and x-axis at 1 and parallel to y-axis. Or to draw this plane, we can take another mirror points for this and for this on the opposite face of the points where it will be. Here these two points are on this face, okay, on this face. So to draw the plane we have to take the mirror points. That means we have to take the point with the same intercept along z-axis, but it has to be mirror. That means we have to take the same intercept on the z-axis on the opposite plane. This is the back plane, and this is the front plane. Okay, so here we have been taken as 1 by 2. Here also we can take 1 by 2, and here is one intercept, and here also we can take one intercept. Okay, that means these 2 points, mirror points on this, another its opposite face will be here and here. Okay, now we have to join the 4 points like this. Okay, so this is our required plane having the Miller indices is 1, 0 and 2, which is parallel to the y-axis. Now we have to consider the question number 4. Here I have been asked that you have to draw these 2 planes in one single unit cube. So first we have to find out the intercepts of the corresponding Miller indices will be 1 by 2, infinite and 1 by 2. I have been written directly. Okay, I have to write this. If you have to take this will 1 by 2, 1 by 0 and 1 by 2. So it will be 1 by 2, infinite, 1 by 2. Similarly, if we are going to take the reciprocal of these indices, then it will 1 by 2, 1 by 2 and 1 by 0. That will be 1 by 2, 1 by 2, infinite. Okay. So for the plane 2, 0, 2, the intercepts are 1 by 2, infinite, 1 by 2. And for the Miller indices 2, 2, 0, the intercepts are 1 by 2, 1 by 2 and infinite. Here from the intercept we found that this plane has to be parallel with y-axis, This plane, the intercept is infinite for z, that means it has to be parallel with z-axis. So now we have to draw the planes. For that we have to draw a unit q. draw this figure here because in video it could not be visualized, maybe because the focus is up to here. Okay, so I have to draw this figure here. So the unit cube, first we have to draw, and then we have to locate the intercepts, and then we have to draw the plane, required plane. So this is our x and this is our y direction, this is our z direction, or we can say this is translation vector a direction, b direction and c direction. Now we have to consider the first intercept. The first intercept is 1 by 2, means on the x-axis 1 by 2 you have to consider. On the y-axis it is infinite, that means the plane has to be parallel to the y-axis, and on the z it has to be 1 by 2. So for this one the intercepts will be here and will be here, and it has to be parallel to the y-axis. For that, as it is 2 in this plane, we have to consider another 2 points on the front plane with equal intercepts. So here we have to consider another 2 points. For this one will be here this much, for this one will be this much. So we have to join the 4 points only. After joining, we found the required plane. Okay, so this is the plane having Miller indices is 2, 0, 2, or having the intercepts 1 by 2, infinite 1 by 2, and this plane represents that it parallel with the y-axis. Now we have to consider another plane having the Miller indices 2, 2, 0, and the intercept is 1 by 2, 1 by 2 and infinite. That means it has to be parallel with z-axis. First we have to locate this intercept on the axis. So on the axis, x-axis, it will be here. Okay. On the y-axis, it will be here. Okay, it will be here. So as the 2 points on this plane at the bottom plane, hence we have to consider another 2 mirror points on the top plane. Top plane means here. It will be here. So now we have to join the 4 points. Now I have been joined the 4 points to construct the required plane. So this is nothing but is our plane having the Miller indices is 2, 2, 0, or the intercepts 1 by 2, 1 by 2 and infinite. So you can draw these two figure or 2 planes with a separate figure also. So now we have to consider the next question, that is question number 5. Question number 5 having the Miller indices is 0, 2 and 3. The question number 5 having the Miller indices is 0, 2 and 3. Okay. If it is so, then first we have to find out the reciprocal of this Miller indices, that will be 1 by 0, 1 by 2, 1 by 3, that will be infinite, 1 by 2 and 1 by 3. Okay. So these are nothing but the intercepts of the plane, whatever we want to draw in the unit cube. For that we have to draw a unit cube first. First we have to draw a unit cube, that is this one. See, here I have been taken x along this axis, or a along this way, and z along this way, and y axis along this way. But you can take as your wish. You can take this way as x-axis, this way as y-axis, this way as z-axis, as your wish you can take, and you have to be conscious about your intercept. Whenever you have to mark the intercept, at that time you have to be conscious. Okay. Now here it indicates that from the intercept it indicates that it has to be parallel. The plane has to be parallel with x-axis. That means its intercept, x-intercept is infinite, means this plane has to be parallel with x-axis. First we have to locate all the intercepts on the each and every axis. So x-intercept is infinite, leave it. Y-intercept is 1 by 2 here. Okay, and your z-intercept is 1 by 3. That means around approximately here. If approximately just here. Okay, the point will be here, 1 by 3, 1 by 3 and 1 by 3. Okay, now we got the 2 points in this plane. So similarly mirror points we can consider on this plane, that it will be here, and another will be here. Okay. Okay, now we have to just simply join the lines like this. This is nothing but is our required plane having the Miller indices 0 to 3, which is parallel to the x-axis. So here we have been discussed of the questions that we have to draw the planes from the Miller indices. And also in the video number 1, I have been given some planes that you have to find out the Miller indices, that we have to be discussed now. Okay. In video number 1, also I given some questions that already plane we have to find out the Miller indices of the plane. So how we have to find out the Miller indices of a plane? For that we have to follow some steps. In detail I have been discussed in that video number 1, and here I just with insert I have been discussed here that if we have a plane, then first we have to find out the intercepts. That means where the plane cuts the axis, and then we have to take the reciprocal of the intercepts. Then we have to enclose the reciprocals by circular bracket without any comma. Okay, so first we have to do the first question, that is this is the plane, what will be the Miller indices. If we have to follow the first step to find out the intercepts, so it cuts the x-axis at 1 by 2. First step we have to follow 1 by 2, then y-axis at 1 by 2, z-axis at 1 by 2. Okay. Now we have to take the reciprocal of these intercepts. Reciprocal means it will be 2, 2 and 2. Then we have to enclose the result, whatever we found, by considering 1 and 2 step by circular bracket without any comma. We have to remove this comma and we have to enclose these values by circular bracket. This is nothing but our so-called Miller indices of the plane, this one. Okay. Now we have to consider this plane. First we have to find out the intercepts. So this plane cuts the x-axis at 1 unit. Okay. Y-axis where it will be cut? If the plane will be like this, it will be cut at infinite. Okay. If this plane will be cut at infinite on the x-axis, y-axis. That means this plane will be cut the y-axis at infinite. Hence the intercept for the y-axis will be infinite, and z-axis it cuts at 1. Okay, now we have to take the reciprocal by considering the step 2. It will be 1 by 1, will be 1, and 1 by infinite, and 1 by 1 I have to write, it will be better for you. 1 by 1 I have been taken the reciprocal. That means it will be equal to 1, 0, 1. By considering step 2, we found that 1, 0, 1 and it's a so-called Miller indices will be enclosed by circular bracket by removing these commas. So this is the required Miller indices of the plane, this one. Okay, now we have to consider this question. For this question, we have to find out first the intercept. X intercept is 1, y intercept is again 1, z intercept is 1 by 2. Okay, now we have to take the reciprocal by considering the step 2, that will be 1 by 1, 1 by 1 and 2. Okay, that will be equal to 1, 1, 2. Okay, considering third step, that only we have to put the bracket without the comma. It will be 1, 1, 2, which represents the Miller indices of this plane. Now we have to consider this plane. This plane having the intercept, that means where it cuts the axis, all the 3 axes intercepts. If we are going to be find out, this plane cuts the x-axis at 1 by 2. That means it will be 1 by 2 is the x-intercept, where it will cut the z-axis and y-axis. If the plane is like this, z-axis is this way and y-axis will be this way. If I will elongate this plane in this direction, then this plane will be cut the z-axis at infinite, y-axis at infinite. So the y and z intercepts of this plane will be infinite and infinite. So now take the reciprocal. It will be 2, 0 and no, I have to write that it will be 2. Reciprocal means 1 by infinite and then 1 by infinite. That will be equal to 2, 0, 0. Now we have to put the enclosed, put the bracket without comma. It will be 2, 0, 0. So this is the required Miller indices of the plane, this one. This is the required Miller indices of the plane, this one. Now we have to go for the fifth question. Now so this is the fifth one. Okay, this is the fifth questions that we have to discuss now. So in the fifth question, the plane is passed in this way in the cube. So considering the steps, first we have to find out the intercepts. Intercepts for x it will be 1, for z it will be for y it will be 1, and for z it will be infinite, because if the plane will be placed in this way, then if we have to extend in all the side, it will be always parallel to the z axis. That means the plane will be tends to cut the z axis at infinite, right? Now we have to take the reciprocal of these intercepts, that 1 by 1, then 1 by 1, 1 by infinite. That will be equal to 1, 1 and 0. So now we have to put these values in a circular bracket without any comma. That will be 1, 1, 0 in bracket. So this is the required answer or Miller indices of this plane. Okay, so we have been discussed all the questions whatever I given for you for your practice purposes in video number 1. Okay, now we have to go for the questions whatever I given in video number 2. Okay. In video number 2, I given questions which have bar. Miller indices have a bar. So how we have to be solve these problems or questions in detail? The methodology have been discussed in video number 2 or lecture number 2. You can follow that video for your detailed note. But however, I written the insert steps that we have to follow to draw the planes from the Miller indices which have bar, 1 bar, here 3 bar, like this. But previously in video number 1, whatever we have been discussed, the Miller indices and its corresponding plane, there was no bar. But here if we have the bar, then how we have to draw the plane? These are the steps. So first we have to follow the steps for question number 1. Okay. So I have to just read the steps that remove the bar, consider with negative sign, then take the reciprocal, whatever we have to found the from the first step, and then consider the appropriate origin. Here I have been written this third line in with red because this is the important among these steps to draw this type of plane. So then we have to locate the intercepts on the axis and we have to draw the plane. First we have to consider the question number 1, that if this is the Miller indices, we have to remove first the bar and we have to put the negative sign, that will be -1, -1 and -2, right? Now we have to take the reciprocal of these values, that will be -1 by 1, -1 by 1, then 1 by 2, which will be equal to -1, -1 and 2. Okay, so these are the intercepts of the plane whatever we intend to draw in a unit cell. So for that we have to consider the appropriate origin and then locate the intercepts. First we have to draw the unit cell, then we have to consider then the last 2 points. So this is our the unit cell. Okay, you have to draw the unit cell first. Unit cell. In previous questions without any bar, the Miller indices, whatever we have been discussed, we always have been taken the origin will be here. Okay, and this and we drawn the plane. This is x, z and y. Okay, you have to draw the cube perfectly. Here it is not drawn perfectly, but you have to draw the cube. Okay, now previously we taken this point always is the origin for us, but now if we have to take this will be the origin, then how we are going to be locate -1 and -1, because if this is origin, this side is positive x-axis, this side is negative x-axis, right? If it will be origin, to locate the -1 I have to move this side, but this side there is no cube, there is no figure, so hence we have to locate the origin in such a way that on this cube, in such a way that all the intercepts can be found in this cube. Okay, now let this origin is shifted from here to here. Okay, if I will be shift the origin from here to here, I can easily move 1 unit negative along x-axis. So this is our, if this will be origin, this will be z and this will be y, right? So from this point I can move 1 unit negatively along x-axis, that will be here. But if this will be the origin, I have to move again 1 unit negative along y-axis. That means I have to move in this way, because here is the origin, x-axis, y-axis, positive y-axis, negative y-axis, positive z-axis, negative z-axis. So I have to move 1 unit this way, but in this way there is no cube, there is no figure. So only for that we have to choose the required origin will be here. Then we can move 1 unit, negative 1 unit along x axis, negative 1 unit along y axis, and half is the positive for z axis. So here I can give you one suggestion that which axis you have the negative, along that axis you have to move your origin, then you will be get the appropriate origin. So here we found that appropriate origin should have to be here. That means here it will be, this side will be our x, this will be z, and this will be y. Okay, this will be the origin. Now we have to put our the so-called intercepts, whatever we have been found here. The following the fourth step, locate the intercepts on the axis. So along negative x-axis, along negative x-axis the point will be here. Along negative y-axis, if we have to move, the point will be here, and along positive the intercept will be half. Okay, we got these 3 points. We have to just connect these 3 points. This is the required plane having the Miller indices 1 bar, 1 bar, 2. Now we have to go for the second one, that is 0, 0, 3 bar. Okay, first we have to draw a unit cell, then we have to follow the steps for drawing the required plane. Okay, so this is our initial x, z and y axis. So maybe further it will be changed to searching the after searching the appropriate origin. So first, if we have to consider the first point, it will be 0, remove the bar and it will be put as the negative, so -3. Okay, first step. Second step, we have to take the reciprocal. This will be 1 by 0, 1 by 0 minus 1 by 3. That will be equal to infinite, infinite and minus 1 by 3. So these are nothing but the intercepts of the axis. Okay, so here minus infinitive, infinitive for x and y, that means blindly we can accept that the plane has to be parallel with both x and y axis. However, it has to be cut the z axis at minus 1 by 3. So if we are going to take this will be as our origin, I have to move this way for 1 by 3rd unit, but this way there is no cube present or figure is present. So only for that, as I said to you that you have to take or you have to shift the origin in that direction where the intercepts are negative. Here the negative is z. We have to shift along the z origin. That means initially it was here. So after shifting it will be here. That means the origin has been considered to be here. So here this will be x and y and z. Okay, now we have to locate our intercepts. If we are going to locate that the x and y is infinite, leave it. Z will be 1/3. This is 1/3, means 1/3. That means we have to draw a plane in such a way that it has to cut this point and parallel to both x and y axis. It will be like this. Okay, so this plane cuts the z at 1 by 3. You can say any z axis you have to consider, then it cuts 1 by 3 but negative 1 by 3, because we have been taken the origin will be here, negative 1 by 3 and parallel with both x and y axis. That means the plane has been cuts the x and y axis at infinite and infinite respectively. Now we have to consider this one. Here first we have to remove the bar and considering the negative, take the reciprocal 1 by 0, 1 by 0 wait, I have been drawn here the same one, no? So this will be wait 0. Actually this is the question number 3. I mistakenly written. In your video you can see that this is the question number 3 and the question number 2 is 0 2 bar 0, that is 0 2 bar 0. Okay, so here it will be 0 and minus 2 and 0, right? Now we have to take the reciprocal. It will be 1 by 0, minus 1 by 2 and 0 1 by 0. That will be infinite, minus 1 by 2 and infinite. So these are the intercepts that we have to consider to draw the plane. That means here infinite along x and z axis means the plane whatever we have to draw, it has to be caught the y axis at minus 1 by 2 and has to be parallel with both x and z axis. First we have to draw the unit cell. X, y and z. So here the initial origin was here, but as it is negative we have to consider the origin will be here. So how much distance we have to move along y axis? That will be minus 1 by 2. The point will be here and the plane has to be parallel with both x and z axis. That means this one means all the y axis it has to be caught at 1 by 2 1 by 2 1 by 2. This is one y axis which is parallel to y axis. This one also parallel to y axis. So on the all the y axis it has to caught at 1 by 2 1 by 2 1 by 2. Okay, minus 1 by 2 as it is origin, minus 1 by 2, like that. So this is our required plane having the Miller indices 0 2 bar and 2, right? Now we have to consider this Miller indices, and first we have to consider its first step, that is minus 2 0 and 1, and then it will be minus 1 by 2 minus 1 by 0 and 1 by 1. That will be equal to minus 1 by 2 and infinite and 1. So this is the required intercepts we have to consider to draw the plane. So first we have to draw the unit cell, that is, and then we have to consider the appropriate origin. Okay, then we have to consider the appropriate origin. So here negative is along x axis, so blindly we have to take the origin will be here. The initial it was here, but here the after shifting the origin will be here, hence the axis will be like this, z, and this way will be y, right? Now we have to look at the intercepts. So negative x axis we have to move 1 by 2, and 1 unit we have to move positive along positive z axis, that means here. So we got the 2 points. So how we have to draw the plane? That will be, we have to consider another point here, because these 2 points are in the back plane. So we have to consider another 2 points on the front. It will be here, right? So the planes will be like this. Okay, the planes will be like this, which will be parallel to the y axis. Okay, next we have to move for the fifth number question, that is fifth number question. We have to draw the 3 planes in one single unit cell, that will be 1 bar 1 bar 0, fifth number question. Okay, 1 bar 0, then 2 bar 0, and then 3 bar 0, right? So how we have to draw these things? Okay, so what we have to do? First we have to remove the bar, that will be -1, 0, it will be -2, 0, and it will be -3, 0. Then we have to take the reciprocal, it will be -1, and infinite, and it will be -1/2, -1/2, infinite. Okay, you can put the bracket, no problem, because here I have been put the comma. Comma means it will represent the intercept. If we have to put the bracket, no problem. Then another intercept will be -1/3, -1/3, and infinite, right? After taking the intercepts, a reciprocal of this, and this. So here minus we found along x and y. So along x and y, that means we have to move the original origin from here to here. Okay, so that means this side will be our secondary, but after shifting the origin from here to here, this will be the y and this will be the our z. Okay, now we have to draw one by one. So here for this Miller indices, the intercepts are -1, infinite. That means -1 along x-axis, -1 along -1 along x-axis, and -1 along y-axis. The 2 points we found, and opposite 2 points have been considered, and we have to join the 4 points. We can found the required plane is this one. Okay. Now we have to consider another half, minus half, infinite. So minus half, infinite means it will be here minus half and minus half. Again we have to consider this point, then we have to draw this. Okay, so this will be another plane. Now we have to consider 1/3, -1/3, -1/3, and infinite. -1/3 along x-axis, that will be approximately here, and along y-axis will be here. We have to take opposite 2 points here and here, and we are going to be joined, and we found this one. So these planes are parallel with each other. Only for that I given that you have to perceive, and you are going to understand that in this way we can found, or we can construct the planes which will be parallel with each other, right? Now we have to consider, go for the 6th question, 1 bar, and 1 bar. 1 bar, and 1 bar. 6th number question is 1 bar, and 1 bar. The 6th number question is 1 bar, 1 bar. So first we have to, in this figure I will do no problem. Okay, so 1 by 2, 1 bar means -1, it will be -1 and -1. Taking the reciprocal also it will be -1, that we have to be considered. So -1, for that all the three are the minus, so we can take this will be the origin, means this will be the origin, means along all the axis we have to go backward. Okay, so we have to go back, or we have to shift 1 unit along y-axis, 1 unit x-axis, 1 unit z-axis, and we are going to get the appropriate origin will be here, and we have to go 1 unit intercept along y axis, along x axis, along z axis. So after joining these three, we are going to get the required plane having the Miller indices 1 bar, 1 bar and 1 bar. Now we have to consider, that is 2 bar, 2 bar and 2 bar. Okay, 2 bar, 2 bar, 2 bar, that is the 7th number question. 2 bar, 2 bar and 2 bar. 2 bar, 2 bar, 2 bar. This is the Miller indices has been given. For that we have to draw the unit cell. Suppose the initial axes are x, z and y in this way. So to draw this one, first we have to remove the bar, and it will be -2, -2 and -2 and take the reciprocal. Okay, take the reciprocal means it will be -1/2, -1/2 and -1/2. So these are the intercepts of the required plane, that what we intend to draw in this cube. So for that, the origin will be, initially it will be here. Okay, it will be at here because all three are minus. So from this we have to move negative x axis 1/2, y axis 1/2 minus z axis also 1/2. That means here origin means the x axis will be like this, and the y axis will be like this, and the z axis positive z axis like this. But we have to move half units along x, y, z negatively, means here half along x, along -1/2 along y, on the y. Here we have to take the point on the axis. Okay, and z also 1/2, and we have to join these 3 points. Then we are going to get the required plane having the Miller indices 2 bar, 2 bar and 2 bar. And in this video also, in this video number 2 also, I given some planes that you have to find out the Miller indices by considering the appropriate origin. Means that planes will become in the form of bar. Okay, now we have to discuss that 3 questions. 3 questions I think given to you in that video number 2. That plane is there and you have to find out the Miller indices. That 3 questions we are going to be discussed now. Okay, in that video number 2 also I given some questions. Video number 2 or lecture number 2, at the end also I given these 3 questions that you have to find out the Miller indices of these planes. Okay, so to find out these Miller indices of these planes, how we are going to find out, the detailed methodology we have been discussed in that video. You can follow for the detailed methodology for your note, but in short I have been written the methodology what we have to follow to draw or to find out the Miller indices of these planes. That first the important is to locate the origin and find out the intercepts of the plane from that origin. Then we have to take the reciprocals of the intercepts and put the circular bracket without comma. Here I not written without comma, and if wherever the negative sign we have to put the bar, right? So first we have to consider this question. So the appropriate origin in such a way that locate the origin or the appropriate origin we have to locate in such a way that from that origin we can get the intercepts. That means we can see or we can visualize wherever we have to take the origin. If we have to be sit on the origin, we can found the cut marks of the plane for the axis. So here I can say I can give one example through this question, that if we have to consider this will be the origin, this will be the origin, we can find that the plane is cuts here and here. Okay, if we are going to consider this will be the origin, this point will be the origin, we can find the plane is cuts here, but we could not found that this cuts for what axis, or this intercept for what axis. If we have to consider this will be the origin, then we can find along this axis or along x axis will be one cut or one intercept here, along y axis one cut or one intercept here. So if it is origin is shifted to here, so this way is our new axis x, and this way is y, and this way is our z, right? So if it is origin, so this intercept is half distance along the y axis, but negative. This is positive y axis, this side is negative y axis, so this will be minus half, and this distance will be plus half along x axis, and this plane is cuts the z axis at infinite. This plane is like this and z axis is like this, this will be cut at z axis. So the corresponding intercepts are 1 by 2 x along x. Look at the origin we have been considering, find the intercepts. So along x it has to be cut at 1 by 2, along y will be minus 1 by 2, and along z it will be infinite. Now we have to take the reciprocal. If we have to consider the reciprocal, it will be 2 minus 2 and 0. Now we have to, whatever the value we have found, we have to put in the circular bracket, removing all the commas, and put the bar if we have the negative. So it will be 2, 2, 0 inside the bracket over bar. This is the required Miller indices of this plane. Now we have to consider this plane. See, this plane is like this. So this is the cube. This plane is like this, okay, like this. So here I named A, B, C, D. There maybe it will be in your video it will be A, B, O, E, right? O, E, okay. So O, E. So how we have to find out the Miller indices? We have to follow the steps. That first we have to consider the appropriate origin in such a way that from the origin we can find the intercepts. See, if we have to consider this will be the origin, we can find one intercept here and one intercept here, and this plane is parallel to this axis. That means if it will be origin, this way is our y and this way is our z. So here I written mistakenly, this will be z, okay, this will be y. So now if it will be origin, if I have to move minus 1 distance, then I am going to reach at this point. So x intercept is minus 1, z axis y intercept, if the plane will be like this and y axis is like this, it will be cut at infinite distance. So the y intercept is infinite, z intercept is 1. So if it is origin, I have to move positive 1 unit, and I am going to reach at this point. So it will be 1. Now we have to take the reciprocal, then the reciprocal will be minus 1, 0 and 1. Now we have to put these values in the bracket without any comma, putting the bar over negative sign. So 1 bar, 0, 1 bar is the required Miller indices of this plane. Okay, now we have to consider this one. So for this one, the origin will be considered as here. The origin will be considered as here. This question already we have been done in our last in previously just we have been done, and if it will like this, then we have to consider this will be the origin. Then here this side is x, this side is y axis, this side is z axis. So the intercepts, if we have to consider this will be the origin, the intercepts along x will be 1 minus 1 by 2. Okay, along z, along y is minus 1 by 2, and along z is minus 1 by 2, right? Now we have to take the reciprocal of these values, then we can find minus 2 and minus 2. Okay, now the Miller indices will be put the bracket, remove the negative and remove the comma. So put the bracket, 2 bar and 2 bar will be the so called Miller indices of this plane. So we have been discussed all the questions whatever I given for your practice in video number 1 and video number 2. I suggest to you that first you go through the video number 1 and 2 for your theoretical understanding how to draw the Miller indices of a crystallographic plane, or from the plane how we have to find out the Miller indices. The theoretical part or the note if you want to write for your exam, that you can found from video number 1 and video number 2, and this video is for you that you have to match your answers whatever you have been done, whatever you have been done for these questions. Okay, so I explain all the questions, so watch this video and try to match and try to clarify yourself. Thank you so much for watching this one.